Lehman about his work in cancer research. Dr. Lehman has had over 30 years of experience in this field, published numerous articles, is the inventor of numerous drug-targeting therapies, and was the recipient of the 2015 American Chemical Society's Award for Cancer Research. He has worked at companies such as GlaxoSmithKline, Ionis Pharmaceuticals, and for the past 19 years, Indecyte, right here in West Lafayette. Not only is he an award-winning scientist, but he's also Evan's father. Can you wave to us from the crowd, Evan? Where are you? There he is. Shh, guys. Dr. Lehman's discoveries are revolutionizing precision medicine with the potential to treat many diseases that affect many people. So, please give a big, greater welcome to Dr. Chris Lehman.
Today. I was expecting only 9th graders here, but I guess I got a mix of everything. Well, it's a pleasure here. I thank Ms. Cowan for the invitation. And I know quite a few of you here. I've coached softball, baseball for a number of years, so I recognize a lot of faces. All you guys are getting too grown up. So this is a different hat that I'm going to wear today outside of coaching. I'm going to tell you a little bit about cancer research. I know you've done this, or at least reviewed some of the concepts of cancer recently, and for those of you older students probably have seen it a few times. I'm going to try to put it into a different context. It's one thing to learn it in a textbook, to memorize facts, and to forget it. Or maybe you'll retain a few things if you certainly don't use those facts very often. But what I'm going to try to do is integrate some of the facts that you just recently learned into what I'm doing, and hopefully inspire a few of you, if not all of you, to go into an interesting field like this. So, targeting drugs. I first want to introduce this topic. Of course, just a few words about cancer in general. If you haven't already experienced this, at some point in your life, you're going to know someone close to you that gets cancer. Cancer is a bad word, but every day that goes by, more and more exciting advancements have occurred that allow people to live longer and in some cases get cured. There's a fascinating field which I'm going to end up my talk today dealing with immunotherapy, which the immune system in your body is probably the best drug your body will ever have, and I'll tell you why towards the end of my talk. But what I wanted to do is spend just a moment telling you about cancer and then segue into what we can do to treat it. So, along the way, someone may end up having a tumor. And you'll see this can be detected by many ways, through CT imaging or whatnot, but generally a person doesn't feel well and they go in and get checked out and they find out they have cancer. What is interesting to especially the young is to understand that cancer is really your own cells. It's your own cells that have lost the ability to control how they divide. I mean, all the cells in our body may divide, except for possibly brain cells. You know, they have to divide from time to time, but they have certain checkpoints that say, okay, you're done dividing, let's move on, or stay quiet for a while. And there's a lot of controls inside the cell that tells it to do that. Well, when a cell becomes cancerous, these controls are not controlled. There's the ability of a cell, one single cell, can then start to multiply and grow and form what we would call a lesion or a small tumor. And these cells will release factors, they'll release compounds, and those compounds will actually attract this blood cell here to start growing towards it. Why? It's because that tumor needs to be fed. It needs oxygen, it needs nutrients, and that's the bloodstream is the supply of those nutrients. And so in time, what you'll see is that tumor, which starts over here, all of a sudden maybe one of these other cells will come out into the bloodstream and go for a little travel throughout the body, and then it'll make a right turn and go outside that blood vessel and will form another tumor. We call that metastasis. And this is how cancer spreads throughout the body. You're not necessarily, or someone's not necessarily going to die from the cancer cells by themselves. It's what those cancer cells do to the vital organs in your body. They will shut them down because they can't control their divisions. They divide, they divide, they divide, and then they overtake. Well, you've probably seen some sort of image that looks like this, where they talk about the different organelles inside of a cell. And again, this is something you'll see in biology. And when I was your age, I didn't know I was going to become a scientist. I really didn't. And I would look at these things, I'd memorize, I'd understand. But then if you don't really put it in context, you may not fully appreciate the value of understanding what this biology is teaching us. And you find out about the different organelles and their function, just picking one out, the mitochondria. A mitochondrion produces power for the cell, we know that. But some of these other organelles, you've got Golgi, certainly the nucleus, which houses the DNA. There's lots of key features inside of a cell, and that's for the overall survival. But when it comes time to wanting to kill this cell, if this is cancerous, we take a look at this and say, well, all right, to survive, that cell needs to make DNA, it needs to make RNA, it needs to make protein. It has key enzymes that control the metabolism within that cell. Transcription factors, which controls how genes are expressed. Not all your genes are expressed at any one time. Some are, some are not. And that's under tight control, usually. Sorry for that, far away. And also everything that's involved in cell division. So you look at this and say, well, what are good targets to inhibit cell and kill that cell? Because that's the goal. We want to kill the cancer. Here we have another image of a cell, and you can see that on the surface there's proteins, and these proteins, some of them are receptors, some of them are transporters, some of them are just there as tags. But we do know that if this is, for example, a growth factor receptor, if something binds to that receptor, it will trigger a cascade of events. We call this signaling. It will cascade these signals inside the cell to tell it to do something. All right, so if insulin binds to your cell, it will trigger what? Glucose to come in. If this one growth factor, called epidermal growth factor receptor, if that binds its ligand and triggers all this communication here from the cell surface to the nucleus, it may tell that cell to divide. And guess what? Cancer, which is derived from your normal cell, has this ability. But whereas your normal cells won't do this, or they be under tight control, this cancer cell will keep growing. So I want to talk to you about what we can do to treat cancer. Because if you see someone that has cancer, and actually it's very close to me, I didn't, again, know I was going to be a scientist. I thought I'd go into medicine just for the hell of it. I didn't really have a goal. But 2 years into college, Evan's grandmother, who we never met, because she died 17 years before he was even born, she died from pancreatic cancer. And she was younger than I am now. It took her life in 5 months. And that's why I said at the beginning, when you understand, you meet people, or know people, your family, your friends that get cancer, when they get treated with drugs, most of the drugs do nothing but make the person sick. Maybe they'll live another month, maybe 2 months, but they have to endure all that toxicity. And that's exactly what I saw when my mother was treated. Lots of toxicity. And in the end, she didn't live very long. So going through that experience, they said, all right, you got a choice. I had a choice. I can do nothing about it and accept it. Or I can change the course of my life and maybe try to do something about it. And so I want to share with you a little bit about that. First, I want to contrast and compare what the traditional chemo is to the targeted chemo. And the targeted chemo is really why I'm here. Non-targeted chemo, if you have an injection, if someone gets an injection, for this illustration, the drug is red. You inject that, and that drug goes everywhere. It goes into all your tissues. It goes into tissues you don't want that drug in. And chemo is essentially poison. It is meant to kill.